So in this video, we want to cover processing a detailed survey of a stretch of road, and then we want to take it through to doing a quick redesign on the surface, and then taking that back out to the field to actually process, to actually set out the new surface. So what we've got is Trimble Business Center is open. We're going to open a new template. So we're just going to choose that metric scale only. Until you have your own template set up, then we'll just choose the default metric scale only. And then we need to take the data in, and I have some data in from a detailed survey, and it's a job file that we basically need to drag and drop into Trimble Business Center. You get confirmed that it's scale factor 1, so we're not using a GPS receiver here, we're just using the total station, so it's an entirely local survey. And what we see here is basically the raw data displayed. I'm going to open the flags window, so I just hit the flags at the bottom, and I can see here that there's nothing untoward apart from a missing code library. I'm going to turn off the grid, so I'm just going to use this toggle to turn off the grid. And as there's no warnings and it looks fine, then what we can do is actually use the View Filter Manager, which can be opened from here, from the Home tab. And I generally always leave it open in the left-hand side of the screen, and we're basically just toggling between the Project Explorer and the View Filter Manager. And the View Filter Manager basically allows us to display or controls what we display on the screen at any one time. And we don't need the total station vectors anymore, and we don't need the azimuth, and we're left with basically just a series of coded points. And by clicking these points, then I can see that this was coded as road edge 2. Now, the feature code library that was used for this survey was the PDU library. So this would normally be saved to a template, so you don't need to import it all the time. But if I want to just grab that PDU code template and drag and drop it in, then now when we go to survey, process feature codes, it's going to look at the feature code for each point, and it's going to apply the appropriate line work and text for that point. And you can see here that we basically have that now, that it's actually applying the suitable text for the stations and the suitable line work for all the other points. We could turn on levels, but at the moment that feature code is not being set to turn on levels. If I wanted to control that, then we could go back in, or we wanted to do it manually, then we could go into here and select points, and we could choose we go into instead of the tables, we go into our labels, and we can say, okay, let's just try that we want to apply just spot levels. So that one is called DCM elevation. We can put them in a certain layer, so let's just put them in a layer called levels. And then we could select the heap of points, select them all, and then we can just choose add, and it's basically applying the levels as we want. Now we can control, because of all of these labels are controlled by paper scaling. Then if we go to project settings and we go to view and we go to the plan view, then we can change this down to a 1 to 200 survey, and all the text, including the stations and everything, will be reduced to a level that is suitable. Now these levels as well, they can be set to align to the strings. So that's something that we can set up in consultation with yourselves later on. So basically what we now have is a partially finished survey, or completely finished survey, but partially it needs some editing to make it complete. So what I'm going to do is just select this line. So we'll just close the label points. And these are the sort of typical edits that we'll need to do. Select that line, right click, choose join. And we're now going to select this line, and it says there's a 9.811 gap. Is that fine? Yes. We then reselect our baseline to be the center line. We then join this one, 9.973 gap, that's fine. We reselect our baseline, which is now this one, and we join, and that's that, now complete. So the next thing we need to do is generate a surface. So once we've got our survey complete, then we can basically just go into our surfaces. We're going to create a new surface. and I'm going to call this OGL, Original Ground Level Survey. I'm going to select everything, and we can basically just hit apply. The stations are automatically ignored because they're set up in a way that they'll never be put into the surface, which is what we want. By default, and again, we can change this in our template, then it will create all these long triangles. So often the first thing that we're going to do is select the actual triangulated network and go into the plan view, go into the properties, and we can say that the maximum edge length, and we can say we don't want to form any edges over 15 meters. And what we now see is we've got a triangulated network all the way along the road. We can inspect this a little bit further by going into the surface slicer view, so we can slice through the road so we can see the center line and the camber on the road. And we can go all the way through and check what that existing survey is looking like. We can also turn on, so we turn the surface slicer view off. We can also go into 3D view, and we can create some vertical exaggeration. So here I use Control, Shift, and the wheel of the mouse button until this value goes up to about 3. And again, we can just inspect that surface, and we can see roughly the highs and lows along that surface. So once we've done that, then what we generally would do is use our surveyed center line as the basis of the new center line for the new surfacing work. Now the easiest thing to do here is we select the center line, and we want to break the link with the established points. So what I'm going to do is basically just export it out as a DWG, that center line, and we can see that we want to make sure that it's set to no for export line work as 2D polylines. And I'm just going to export this back out to my D drive and export it. And then when we import it back in, it's no longer got any association with the points. So then we can start to edit it. So we just basically drag that center line back in. So what we now should have is we should have the CAD 3D polyline that's been imported back in. And what I want to do here is I want to just change the layer. So I'm just going to put this in a new layer called New Center Line. We can change the color, so we'll say turn it green. And then what we can do is we can say that we're raising the road surface from where it's surveyed by 50 millimeters, say. So we can go into CAD and we can say we're going to change the elevation to delta elevation, and we're going to raise that by 50 millimeters. And when I go into the 3D view, what we should see here is the old center line and the new center line raised 50 millimeters. What we can now do is we can go into this string. We can choose edit, and we can see that we've got line string. And what we can do is we can edit anything in this line string. So if I just go anywhere on this line, then we can see all the different heights, and we can edit anything. We can raise it, we can lower it, we can have high points and low points throughout that road. So anything on that alignment we can change. It's currently a line string rather than an alignment. So to actually build a road from it, what we'd normally do is select it, and we'd go into corridors, create alignment, and then we can call this new road center line. We'll put it in the same layer as the line string, new center line. We're going to use that existing line, which is that one there, and hit OK. And now we've got another way of editing the alignment, so we can go in here and again we can change any of the levels here for the various changes to change that alignment. But once we've got an alignment, we can now actually build a new road surface. So we go to create corridor. We can say this is a new road surface, and I can choose as a reference surface just to tick the OGL surface, and at least it means that we can see the existing surface when we're actually creating the new road. And we can just hit OK. We're going to start chainage 0 of that road, and what we should now see is we should see the cross-section view through the road. Now I'll just turn off the grid view. So we see here at chainage 0, which we can see displayed here. We're only seeing the left-hand side because there might be a slight stagger. So if I just move it on a fraction, now we see that if we move half a meter on, then the right side comes into play, and it's just because there's a slight stagger between these two surfaces. So we can see the left-hand side is 0.42, and then we can see what's happening in the camber there. So what I can do is I can just go in and we can create these instructions. And what I'll do is choose an offset slope from the center line. And I'll say that we want to go, and let me just check. The existing is 2.816. Well, let's go for 2.75. And let's say that we want to have the grade on this side of the road. Let's go for minus 2.5%. And we'll just call this, we can give it a name if we want, so we can just call it channel left and hit add. And we can see now, as we see, I've actually added on the right hand side, so let me just go back and edit that. And we're going to say that it's actually minus 2.75. And we can see this is the road surface. And it will basically use that template until it's been told differently. So if I go all the way along the 500 meters of the road, then we can see that's been formed. And we're actually, this chainage 0 is up at the top. So we can see what it's actually forming there is this new surface here. And we can see the two surfaces interacting here. And then let's just flick it across to the other side as well. So just use mirror instructions. And it's just going to allow me to see the two sides of the road. And then we can start going through and having a look at it. Now, I can see the camber fluctuates a little bit. So I can start making a judgment and I can say, well, that looks probably okay. And then we're getting obviously and we're definitely sort of starting to see a camber more towards the right hand side. So if we decided, okay, let's change 150, let's start, or let's say we want to start the transition at change 137. Then what we can do is we can just go in and say we want to insert a new corridor template at change 137. And we're going to copy the definition that we've got from 0. And it basically just means that between these two changes, then it's 0 and 137, then it's not going to do anything. If I want to then say at change 172, we're now actually got in a situation where we've got full crossfall to the right, then we can just go in and say we're going to insert a new corridor template at change 172. And we're going to copy the definition from 137. But this time we want to edit it. So we're going to edit the left-hand side here to be plus 2.5%. So we'll just take that out and we'll hit save. And what we should now see is that as I move the chainage up to 137, it's all standard camber. And then we start to see a transition across to crossfall. And then if I decide by the time that we get to chainage, say, let's say it goes back to camber at to normal camber at 215, then we can say insert corridor template at 215, and we're going to take a copy of one with standard camber in it, which is that one there. And then we can say when we go for a little bit further, we're at 272 and we get crossfall to the right. Then we can say insert a new corridor template at 278, and this time it is. And we'll just use the basis for it, a normal camber. But this time we want to go in and edit the right hand side. And we're going to take out that minus 2.5% and hit save. So that's 278 all the way around. And then maybe we're going to stop the transition at 357. Insert corridor template at 357. And we can see that this is going to be a copy of this one here. So it's going to hold that. And then let's just say by the time we get to the end of the road at 504, or we need to, so let's say that We're going to stop the transition at 452. Or we're just going to slowly transition all the way through to camber at the end. That's what we'll do. So we're just going to go to 502.77, 502.77, and we're going to take one of the camber ones. And essentially what it's going to do is it's going to, whenever the templates change, it's going to slowly transition between the two templates. 502.77. And we can verify that just by going through, and we can see how they interact as we go all the way through. And that is basically formed a new road design based on what's there. What we can do is once we've got that new surface, and if we go to the plan view again, obviously we can go to the surface slicer view. So we go to surfaces, surface slicer, we see the two surfaces there. We can calculate some volumes. So we can go to surfaces, earthworks report, and we can say, okay, what's the volume between the OGL and the new road surface? And it tells us how much material we're actually going to need to put in there. So it's 123.8 cubic meters of material. We could break it down into the various bands, but most of the time I'm guessing you're going to be using the standard top course only. So we just need a single volume. Now what we need to do is export this. Once we've got this surface, is export this surface onto the controller. So if we are going to a controller that has a roads module, then what we want to do is we want to select the design surface, which is this surface here, corridor road design, and we want to select the horizontal alignment. And then we can choose export, and we can choose from the construction, we can choose LandMX XML exporter, and I can call this land XML file. And I'm going to choose triangles as a surface description, and then we can just choose export. So that's if we're going to a controller with the roads module. If we're not going to a controller with the roads module, then what we need to do is select the horizontal alignment, and we need to export this as a DXF file. So we choose DXF, and we export this, making sure that this is set to no. And then separately, what we need to do is grab the surface, the road design surface, and export this under the construction tab as a Trimble terrain model file. So this is if we don't have a controller with the roads module. And the next part of the video we'll go through what we do inside Access. So on the controller we transfer the new design information for the new surface across to the controller, and we create a new job. So this is the survey that we've done, and I'm going to create a new job called Set Out and choose Accept. And often, because we want to reuse the stations that were put in for the survey, we're going to go into our layer manager, and we're going to go across and actually pick the original survey. And it means that all these survey points are now available for me, including the stations. So we're now going to set up the total station on one of the stations, which we're just doing just now. And then we can choose Measure, and we're going to choose Station Setup. And I can select from the map the station we're going to set the instrument up over. We're going to put in our instrument height, and we're going to take our backside and put in our backside height and get established.
Station setup completed.
Now, if we're using a controller without the roads module, then we go to our layer managers, we go across to our map files, and we pull in our road center line, we tick it, and then put the box around it, and we take in our Trimble terrain model, we tick it, and we put the box around it, and choose Accept. And now all we need to do is we now need to just select the actual center line string. We have to be a little bit careful because we can actually, the polyline could be the wrong direction. So if we long press, we can flick the polyline direction around. And then we choose Stakeout. and we just choose stake out to the polyline. And we should see if we're in tracking mode, so we just make sure that we're in tracking mode by checking it here. We should have the T beside it. As we should see our cap fill being shown to the center line here, our cap fill to wherever we are on the road being set here, so you can see that it's 32 mil different, and then our current chainage. So as we move down the road, we can see that these values should update as we progressively move down the road. And obviously we need to be inside the center line to get a cap fill to the road. If we go outside the road surface, so I'll just move outside the road surface, then the cap fill is reported to the center line only. So this is to the center line here, and this is to the center line here. When we're inside the new road surface, then this cut or fill will be to the surface itself. So that's how it works if we're using a controller without the roads module. If we do have the roads module, then we would then not use, we would use the land XML file. We would then select the road itself, stake out, and we can see that it's on alignment. And we can choose to the alignment. And what it's given me here is it's actually giving me the center line, cap fill to the center line, and the cap fill to the center line is what we're displaying here. So it's not showing you the road surface. To show you the road surface, we must go across to the roads module, and then we can choose to the road instead of to the alignment. So what we now see is we still see, even though we're in the roads module, we still see our cap fill to the vertical center line. But if we go to options, then we can say that we want to report it to the land XML surface. And what we now see in this area here is the vertical cap fill to the actual land XML surface. And if we now get our cross-section views within the roads program. So we can at any time go to our cross-section views and display what we're seeing in the actual road. So the benefit of using the roads module is it does give you your chainage perfectly all the time. You don't need to sometimes reverse it. And we do see our cross sections. And lastly, what we can also do is we can put in vertical offsets. So if we wanted to be set 100 mil above that road, then it will basically display the 100 mil above the road, and we can see this offset in place. So that's a quick guide in how to set out a resurface within Trimble Access.